Welcome back to yet another session. It is the second subsession of part 4. So that is topic 4, where we are going to discuss about human comfort and IAQ principles. So I have combined both. So both topics we will complete in this session. So these are the content. Now we are seeing this human comfort and IAQ principles in fourth topic. In next session, we are going to start effective temperature chart. So human comfort. So strictly speaking, the human comfort depends upon psychological and psychological conditions only. It is psychological feeling. Thus, it is difficult to define the term human comfort. There are many definitions given for this term by different bodies. So, but the most accepted definition from subject point of view is given by the ASHRAE. So, that is American Society of Heating, Refrigeration and Air Conditioning Engineers. So, which states that human comfort is that the condition of mind which expresses satisfaction with the thermal environment. So, during normally summer, we don't feel comfort with the environment, and during winter we are very much comfortable. So that is our internal feeling. So the thermal exchange of body with environment, so that is nothing but heat exchange with environment. The human body works best at a certain temperature like any other machine, but it cannot tolerate a wide range of variations in their environmental temperatures like machines. And the human body maintains its thermal equilibrium with the environment by means of three modes of heat transfer. So that is normally evaporation, radiation and convection. The way in which the individual's body maintains itself is comfortable equilibrium will be by its automatic use of one or more of three modes of heat transfer. And a human body feels comfortable when the heat produced by metabolism of human body is equal to the sum of the heat dissipated to the surroundings and the heat stored in human body by rising the temperature by body tissues. So this phenomena may be represented by the following equation. So Qm minus Qw equal to Qe plus or minus Qr plus or minus Qc plus or minus Qs, and Qm minus W equal to heat to be dissipated to the atmosphere, where Qe is heat loss by evaporation and Qr is heat lost or gained by radiation, and Qc is heat loss or gained by convection, and Qs is the heat stored in the body. So these are the different Qs involved here. So it may be noted that the metabolic heat produced Qm, so that is a metabolic Q heat, and depends upon the rate of food energy consumed in the body. A fasting, weak or sick man so will have less metabolic heat production. The heat loss by evaporation is always positive. It depends upon the vapor pressure difference between the skin surface and the surrounding air. The heat loss of evaporation QE is given by, so QE equal to CD into A PR minus PV into HFG into CC, where CD is diffusion coefficient in kg of water evaporated per unit surface area, and pressure difference per hour. A is the skin surface area, human skin surface area. It is 1.8 meter square for a normal man, and it is average area. So PR is equal to saturation vapor pressure corresponding to skin temperature. So PV equal to vapor pressure of surrounding air. So HFG equal to latent heat of vaporization, and CC equal to factor which accounts for clothing warm. So that is the value QE becomes 0 when PR equal to PV. So when the surrounding air temperature is equal to the skin temperature and air is saturated, or when it is higher than the skin temperature, the air is nearly saturated. So the value of QE is never negative, as when PR is less than PV, the skin will not absorb moisture from surrounding air as it is in saturated state. The only way for equalizing the pressure difference is by increasing PR to PV by rise of skin temperature from sensible heat flow from air to skin. The heat loss or gain by radiation QR from body to surrounding depends upon the mean radiant temperature. So here this is QR, it depends on mean radiant temperature. It is average surface temperature of the surrounding objects when properly weighted and varies from place to place inside the room. And when the mean radiant temperature is lower than the dry bulb temperature of air, so here in the room, the QR is positive and the body will undergo a radiant heat loss. So on the other hand, if the mean radiant temperature is higher than the dry bulb temperature of air, so in the room, then QR is said to be negative. So in this case it is positive, and when it is higher then it is negative, and the body will undergo a radiant heat gain. So body will experience heat gain. So now you can see the various conditions here. The body at 22.8 degrees Celsius, 50 percentage of humidity, so 37 degree Celsius. So heat flowing from body to ambient air at just the right rate. So the body's normal temperature is 37 degree Celsius. So now when the ambient temperature is 37.8 degrees Celsius, then the body temperature is 37 itself, then the human body must give off some of its generating heat to the surroundings. So now, so here the heat loss by conduction, and this is the heat loss by convection, and this is heat loss by radiation. So these are the three configurations of human heat transfer. And the water vapor and perspiration, so this is the evaporation and respiration, and this is through evaporation and respiration also the heat transfer takes place. So here this is the environment. The boiler can be compared to the human body in that uses fuel or energy, so it is equivalent, so very much similar. Whatever is happening in the body, human body, so that is happening in a boiler, and it is a correlation, or we can say a analogy. So heat from flue, the system body shown clearly here, and the normal human body temperature is 37 degree Celsius, ambient temperature is 37.8, so room air at 22.8 degrees Celsius, and relative humidity is 50 percentage, and evaporation from skin also shown with the perspiration arrows, and the plus sign is used when heat is lost to the surroundings, and negative sign is used when heat is gained from surroundings, and the plus sign is used when the temperature of the body rises, and negative sign is used when the temperature of the body falls or going low. So thermal exchange of human body and human comfort, heat loss by convection, so that is QC. The heat loss by convection QC from the body to the surrounding is given by, so QC equal to UA into TB minus TS, and where the U is body film coefficient of the heat transfer, and A is body surface area, that is 1.8 meter square for normal man, and TB equal to temperature of the body, and Ts equal to temperature of the surroundings. And when the temperature of the surroundings Ts is higher than the temperature of the body TB, then QC will be negative and the heat will be gained by the body. On the other hand, if the temperature of the surrounding TS is lower than the temperature of the body TB, then QC will be negative. So that is the heat will be lost by the body. And since the body film coefficient of heat transfer increases with the increase in air velocity, therefore higher air velocities will produce uncomfort when TS is higher than TB. The higher air velocities are recommended when TS is lower than TB. So this is what happening here. And when QE, QR and QC all are positive, then QE, QR and QC are positive, then QE plus QR plus QC is greater than QM minus W, then the heat stored in the body QS will be negative, so that is the body temperature falls down, and thus the sick, weak and old or fasting man feels more cold. On the other hand, a man gets fever when high internal body activities increase QM to such an extent so that QS becomes positive for the given QE, QR and QC when the body temperature is higher, where a person gets fever. And heat storage in the body, the heat stored in the body has maximum and minimum limits, which when exceeded brings death. So that is the final happening here. The usual body temperature for normal man, that is QS equal to 0, that is 37 degree Celsius or 98.6 degree Fahrenheit. The temperature of the body when falls below 35.5 degrees Celsius, 96 degree Fahrenheit, and exceeds 40.5 degrees Celsius, so that is 105 degrees Celsius, is very dangerous. So this is a very high fever, and it is actually not recommended. So, vasometer control mechanism. So there is a simple technique. There is some kind of thermostatic control called vasometer control mechanism in the human body, which maintains the temperature of the body at the normal level of 37 degrees Celsius by regulating the blood supply to the skin. So by even by blood circulation also impacts the temperature of the skin, and when the stored temperature of the body falls, that is the heat stored QS is the in the body is negative, then the vasometer controls decreases the circulation of blood, which decreases conductivity of nerve cells and other tissues between the skin and the inner body cells. So this allows skin temperature to fall, but allows higher inner temperature of body cells beneath. And when the temperature of the body rises, the heat stored QS in the body is positive. Then the vasometer control increases blood circulation, which increases conductivity of tissues and hence reduces the temperature drop between the skin and inner body cells. So here the human body feels comfortable when there is no change in body temperature. So when the net heat stored in the body Qs equal to 0, any variation in body temperature acts as a stress to the brain, which ultimately results in either perspiration or shivering. So shivering also happening here. So psychological hazards resulting from heat. So heat exhaustion. So it is due to deficiency of normal blood circulation. The symptoms of heat exhaustion includes fatigue, headache, dizziness, vomiting, abdominal mental reactions such as irritability. So severe heat exhaustion may cause fainting, so fainting also possible. It doesn't cause permanent injury to the body, and recovery is usually rapid when the person is removed to a cold place. So heat cramp, so another hazard is heat cramp. It results from the loss of salt due to an excessive rate of body perspiration. So it causes severe pain in the calf and thigh muscles. The heat cramp may be largely avoided by using salt tablets. So heat stroke, it is a very dangerous hazard, and it is the most serious hazard. When a man is exposed to excessive heat and work, the body temperature may rise rapidly to 40.5 degrees Celsius, that is 105 degree Fahrenheit or higher. So at such elevated temperature, the sweating seizes the body. The man may enter a coma also. So coma is where there will not be any senses in the body, and the death also possible. A person experiencing heat stroke may have permanent damage to the brain. The heat stroke may be avoided by taking sufficient water or frequent intervals. It has been found that a man doing hard work in the sun requires about 1 liter of water per hour. So when a person is working under the sun, then definitely he requires more water. Always the body should be kept in a hydrated state. So factors affecting human comfort. So in design, winter or summer air conditioning system, the designer should be well conversant with the number of factors which psychologically affect human comfort. The important factors are as follows: the effective temperature, heat production and regulation in human body, heat and moisture losses from human body, moisture content of air, quality of air, quality and quantity of air, air motion, hot and cold surfaces, air stratification. So these are the factors and important factors to which influences human comfort. So indoor air quality. So now overview of indoor air quality is indoor air quality is a relatively new subject concerning the standard and the state of excellence of the air in an enclosed surrounding. People are beginning to be aware of the important role it plays on well-being of their health and comfort. As more research is being done to understand its effects and the lives and health of people who spend a large percentage of their time working in confined environments. So now people paying attention to the factors which are actually influencing inside the door. So although the harmful effects of pollution and ambient air were generally known, the results of the scientific investigations in the United States and elsewhere have shown that the air inside the office buildings is contaminated with substantial amounts of toxic airborne contaminants. So, even indoor air is also having the air contaminants. So prolonged exposure to these contaminants by the occupants, particularly in modern buildings, has resulted in many reported outbreaks of illness and diseases. So traditional focus of air conditioning design. So traditionally the air conditioning design is concerned with the maintenance of acceptable thermal and humidity conditions and proper distribution of treated air in a space. However, due to the seriousness of the indoor air quality problems, particularly in air conditioned spaces of necessity, the onus of controlling the indoor pollution has fallen on design as well as on the operation and maintenance of air conditioning systems. So acceptable and non-acceptable IAQ. So now in earlier days, it was only possible to uncertain, unsatisfactory IAQ by sensory fields or after discovering that someone has fallen sick. So then only we will come to know something went wrong in the indoor condition. The nowadays with the introduction of sensitive measuring instruments to measure the quantity of any elements and gases, it is possible to quantify the IAQ of a premises. The distinction between acceptable and non-acceptable levels of IAQ has been better defined in last 15 years. So now many standards are coming up, and there are many sensors to measure different gases or different contaminants inside the room are available. Various standards recommended the acceptable and safe levels of gases and contaminants are particulates which are permissible in an enclosed environment. Generally, the levels of contaminants inside the tightly sealed buildings are very high compared to the outdoor levels, so making it harmful to the health of the occupants. And the aim of the standards is that ideally the air inside the enclosed areas should be as fresh and clean as natural outdoor air. So ASHRAE standards 62 to 89 have gained wide acceptance as benchmark for any local legislation. So factors affecting IAQ in buildings. The current trend in the building industry has been towards constructing structures that are permeable to heat but not to air and humidity. The trend is to construct a relatively airtight box-like enclosure wherein temperature, humidity, and air quality are controlled with the assistance of an air conditioning system. So the air quality of these structures would depend very much on their air conditioning and ventilation systems, and hence it is important then that the air carefully and regularly filtered to remove dust and to prevent the buildup of pollutants if the air is to be recirculated. So building materials and IAQ. So now building materials also have the influence on IAQ. The choice of building materials has substantial effects on the indoor air quality of the building, either by direct interaction with the surrounding air or by defining the temperature and humidity in the building. So wood absorbs and transmits moisture through cracks and holes. All materials that absorb moisture can also filter and absorb particulate, therefore providing an avenue for the formation of airborne molds and fungi, which could be the carriers for bacteria and viruses, making them harmful to human health. So indoor furnishings and IAQ. Indoor furnishings like wall, floor, carpeting have become increasingly common in modern buildings, which tend to absorb most gases, liquid, and particulate air impurities. So now the furnishings also one of the cause and which resulting in this hazardous gases, and that will be released inside the indoor, so that also should be taken care. And air change and infiltration. Natural ventilation, infiltration, and forced ventilation are three forms of air change in the built environment that affect IAQ. Now all buildings are subjected to involuntary filtration one way or other through cracks, doors, windows, and air ducts. Air infiltration depends on wind speed and temperature, the location of the building and its design, and a high indoor humidity level can cause harmful microbes to grow on walls. And on the other hand, if the humidity level is too low, the dry air could cause no, nose and throat viral infections among the occupants of the building. So IAQ codes and standards. Over the years, the IAQ codes have evolved to sophisticated code that is now accepted widely. And one of the earliest codes was ASA 53.1 code entitled Light and Ventilation, published, which dictated the percentage of window opening and should be on the outside of the building provided area for mechanical ventilation. So now these are the standards which are coming up. The ventilation rates were based on the empirical judgment of the heat stress. So ASHRAE standards here. The American National Standards Institute (ANSI), the American Society of Heating, Refrigeration and Air Conditioning Engineers (ASHRAE) jointly developed a ventilation standard, ASHRAE standard 6273. Its most important feature being a ventilation air supply of at least 5 cubic feet per minute per person, based on limiting the carbon dioxide concentration in the air to 2500 parts per million ppm. And following the energy crisis of year 1974, ASHRAE produced standard 9075 energy conservation in buildings, which was followed by standard 62 in 1981. So in the same standard, acceptable indoor air quality was defined as 80% of the people in the space not being dissatisfied. So ASHRAE standard 6289 is updated version of the standard 6281, and the ventilation rate recommended was upward of 15 cubic feet per minute per person, based upon a dilution rate necessary to limit the maximum concentration of carbon dioxide to 1000 ppm. So discomforts and diseases associated with poor IAQ. So now it was only recently realized that poor indoor air quality has an effect on human comfort and health. The adverse effects of poor IAQ can be generally classified in two areas: sick building syndrome, so that is SBS, and building related illness, BRI. So first one is sick building syndrome. So that is SBS. Building syndrome is a recently coined term used to describe varying degrees of discomfort, real or imagined, and poor working conditions reported by occupants of office buildings, both air conditioned and non-air conditioned. SBS is characterized as a group of non-specific complaints by employees in modern sealed buildings, often including headaches, so mucous membrane irritation and dizziness, sore throat, lethargy or fatigue. So mostly these symptoms disappear when the person leaves work. So when he came out of that space, then he will be relieved. So probable causes of SBS: inadequacies or malfunctions in the ventilation system. So deprived intake of fresh air, increased levels of volatile organic compounds, microorganisms in the air. So lack of adequate and appropriate temperature and humidity controls in the building. And common features of SBS, so that is symptoms are non-specific and resemble common cold or respiratory ailments, and complaint severity increases during the day and disappears when the individual is out of the building, and affects newly constructed refurbished energy efficient buildings. Employees have no control over temperature, humidity, ventilation and lighting. So these are we cannot control these parameters. And next one is building related illness. So BRI refers to more serious and medically identifiable diseases with symptoms lasting for an extended period. These symptoms often do not disappear when the person leaves the building. So this will prolong, and the following are categorized BRI illnesses, and one is allergic respiratory diseases, that includes sinusitis, peritonitis, allergic trachobronchitis, ATB, asthma, hypersensitivity, pneumonitis, humidifier fever, and symptoms of sinusitis and Paragnatics include the post-nasal drip, nasal drainage, and these are the symptoms of sinusitis and paragnatics include. And the sore throats, STB, inflammation of upper respiratory tract, tract asthma triggered by dust-laden upholstery, so that leads to coughing, chest tightness, chest pain, and hypersensitivity, that is HP, and allergic lung disorder from organic dust or allergens. And symptoms may be progressive weight loss, fatigue, uh, lethargy, so coughing with a little phlegm. So next, infections. So these are legionnaire disease. So it affects lungs, so gastrointestinal tract, gastrointestinal tract, kidneys, brain, and symptoms are fever, dry cough, chills, chest pains, diarrhea, vomiting, and weight loss. And we have outbreaks linked to aerosols in cooling towers, evaporative condensers, shower heads, water faucets in hospitals. So next, skin diseases are allergic dermatitis, example, and allergies, phototoxicity, irritation associated with the copper and toner fluids, and carbonless copy paper. Symptoms may be dry and itching skin. Pollutants and their sources. Indoor impurities can organized in outdoor air, be carried by outdoor or indoor air, or be generated by building materials, occupants, and their activities. So air impurities are dust, so differentiated and defined by size range. Urban dust contains organic and inorganic materials from industrial sources. Household dust contains biological and inorganic agents, mites, viruses, bacteria, asbestos fibers, and acts as carrier for microbes and other pollutants. So tobacco smoke, a mixture of dust, smoke, aerosols, and vapors. Each cigarette can release billions of particles, average size of zero point 0.2 micron. And allergens, indoor environments is filled with house dust, animal products, so molds, bacteria, pollens, and chemicals. So eliminating allergen sources reduces or stop allergic reactions. So metabolic products, water, main metabolic product released by the body and dissipated via skin, perspiration, and exhaled air. A person may release 3 to 5 kg of water daily by perspiration and exhalation, depending on activity and temperature. Other metabolic contaminants, exhaled air and skin shedding release. So it releases carbon dioxide, ammonia, acetone, skin scales, perspiration, amino acids, hydrocarbons, sugars, enzymes, urea, and dried skin and hair also contribute to indoor dust. So indoor air pollutants, so formaldehyde. So this formaldehyde is colorless gas at room temperature. From it is from insulation, particle boards, plywood, carpets, adhesive resins. So released from cooking, heating, smoking, combustion products from gas, kerosene, wood stove, smoking. And main pollutants are carbon monoxide, use can cause headaches to coma, and nitrogen oxides, NOx, so it can be NO, NO2, and N2O, and cause respiratory infections and lung damage. So particulate materials, airborne combustion products affects lung function, and particles lesser than 2.5 microns are more harmful than larger ones. So that is radon. And radioactive gas from radium decay in soils enters buildings via cracks, subflooring, foundation holes, airborne lead, and from combustion of leaded fuels, mining and smelting. So entry points can be inhalation, ingestion of settled particles. So asbestos, needle-like fibers cause lung cancer, irreversible damage. So used for tensile strength, fiber proofing and insulation. So these asbestos are used for tensile strength and fiber proofing and insulation. So volatile organic compounds VOCs found indoor from floor coverings, paints, varnishes, furnishings, cooking effluents, ambient infiltrations. So common VOCs are toluene. This is very hazardous, and trichlorothenes and naphthalene, benzene, chloroform, so methyl chloride. So VOCs can be absorbed into cell membranes, and it takes into lungs, bloodstream, skin, and digestive tract. And now the microbes includes bacteria, viruses, molds, fungi, spores, pollen transmitted by air. So it may cause chickenpox, smallpox, measles, so tuberculosis, droplet transmission, so Legionella bacteria, cold virus. So adequate ventilation plus filters reduce microbial infections. So instruments for monitoring air pollution. So odor can be monitored relatively easily using our sensory organ nose. So other IAQ parameters such as temperature monitored using thermometer, humidity monitored by hygrometer. For more accurate IOQ analysis, sophisticated instruments are needed, specifically in cases where buildings show signs of occupant suffering. So quantification of indoor air quality IAQ is required. Monitoring techniques, collection of air samples, used media that absorb, strain, trap. So these samples are then quantified. So specific instruments, direct reading calorimetric tubes, so used for measuring concentration of various indoor air pollutants, provides direct reading, and sorbent tubes, glass tubes with packed absorbent material or media. Air is drawn through the tube. Airborne pollutants are trapped or in absorbent media, chemically or thermally desorbed, and analyzer thereafter. So now portable chromatograph, direct reading instruments for investigating indoor air pollutants, equipped with standard chemical detectors and commonly used in chemical laboratories, and infrared spectrophotometers, and these detect carbon dioxide, carbon monoxide, sulfur hexafluoride, nitrous oxide. So detects even low concentrations above 10 parts per million. So pollutant control. So pollutant control requires not only operational and maintenance functions after building construction, but also competent design to ensure better indoor air quality. The essential features of an effective pollutant control program are discussed below. The operational and preventive maintenance plan. So implant a building maintenance operation program with adequate staffing. So sufficient budget is required. A written operations manual should detail step-by-step procedures for all maintenance tasks. Scheduled periodic maintenance is crucial to IAQ. So example, preventive maintenance, painting, coil cleaning. So use of low VOC chemicals. Activities should be done when occupancy is minimal. Ventilation systems must be calibrated, include sensors for airflow and pressure, operate at designated thresholds. So control mechanisms should be part of annual maintenance programs. So materials management program. So chemicals used in housekeeping, pest control, food service, maintenance operations should be evaluated for toxicity. impact on IAQ recommendations: use less toxic or water soluble materials, prefer water based solvents over organic solvents, so minimize purchase and use of hazardous chemicals. So good housekeeping: routine cleaning and vacuuming improves IAQ. So use of HEPA filters in vacuum cleaners is beneficial, and maintenance tasks include removal of stagnant water on roofs and cleaning air conditioner fans, drains, distribution dampers, baffles, leak repair and tile replacement in immediate replacement of wet insulation, rusting piping. So high risk maintenance activities, welding, soldering, etc. should be done in dedicated ventilated facilities. Air distribution ducts must include access ports for vacuuming. Next is filtration. Affects IAQ significantly. Filters remove dirt, pollens, bacteria, insects, dust. Indoor return air contains similar pollutants. So filtration efficiency depends on type of filter, condition of the filter, cleaning and replacement frequency. Filters protect occupants, HVAC equipment, IAQ integrity. Thus, effective pollutant control program integrates the engineering design, maintenance protocols, material safety practices, filtration efficiency. So IAQ considerations in air conditioning system design: any effort towards improving the IAQ of a built environment will be ineffective if at the time of designing the air conditioning system appropriate control and IAQ considerations are not taken into account. So IAQ and air control is very important concepts that should be considered before any construction. So systems, modern trends in HVAC design emphasize energy efficient operation, particularly with variable air volume VAV systems. So these systems are widely used in office buildings, educational institutions, laboratories. Problem with the VAV systems are reduced supply of fresh air at a part load operation results in poor indoor air quality, that is IAQ. Solutions to improve IAQ: incorporate ventilation provisions with adequate control devices and fan powered VAV terminal units. So benefits are improved dilution of contaminants in indoor air, so enhanced IAQ performance even in energy efficient buildings, and studies show energy saving retrofits had minimal impact on IAQ, underscoring the need for deliberate IAQ strategies. So IAQ control strategies. So control of fan operation and damper positioning is crucial. So this is the figure you can see here. So this is the supply fan, and this is air handling unit. The cooling coil is provided here. The supply air is entering into room and departing from room and returning air. So this is the relief dispenser, and this is the outdoor supply. So this is one strategy here. Control of an air operation, fan operation and damper positioning is crucial, and control of supply and air return air. So controls applied to supply and return fans, outdoor supply and relief dampers. So goal here: maintain constant outdoor air rate, manage IOQ through contaminant level control, CO2 concentration monitoring, CO2 sensor controllers commercially available, adjust dampers automatically to meet ventilation rate demands, help maintain healthy air composition, compliance with the ventilation standards. So control of supply and return air. So components: outdoor air supply, air handling unit with cooling coil, supply fan, room return air pathway, relief damper. So purpose, we have to provide all this, and purpose to illustrate mechanical control of airflow, ensures balance between ventilation effectiveness and IAQ maintenance. So outdoor air quality considerations, sources of pollutants, bacteria, fungi, odors, toxic materials, combustion byproducts. So the products due to combustion. So common locations are near traffic, loading docks, exhaust stacks, boiler rooms, toilets, kitchens, cooling towers, and effects. These sources negatively impact air intake quality, HVAC performance, building occupants' health, and preventive measures. Proper planning of intake and exhaust location is very much essential, and best practices place intakes below exhausts. Prevent reintroduction of building exhaust. If pollutant levels are excessive, then consider relocating the building itself. So these are the main concepts, IAQ principles, and we are completing the topic number 4 in our fifth unit. In next session, we will be seeing the next topic in fifth unit, and these are the books. You can refer any of these books. And R.S. Kurmi is a simple book you can refer for this topic. Also, you can refer the C.P. Arora, Rajput. Also, we stop here, students. Thank you. We will meet again in next session. Thank you, students.